All right, now we're going to move on to the next section, and this is section E, and it's called factorizing expressions with four terms. All right, we're going to refer to this as factor by grouping. All right, now the one key thing I want to make sure that you guys understand is when you're going to do factor by grouping, the important thing is that it needs to have four terms. All right, so whenever you have a problem with four terms, the very first way, so whenever you have a problem with four terms, the very first way you should try to factor, or that you're going to try and factor, is factor by grouping. All right, so that's how we know that we are going to use this method, is whenever we have four terms. All right, so before we get into actually doing a problem with factor by grouping, I want to go through and just show you how we can do this. All right, so remember, whenever we factor, that's where we're starting with our problem after we multiplied or after we would have multiplied it, and we're undoing it to see what do we multiply to get together. So if I give you this problem here, x plus 2 times x minus 3, and if you went to multiply this, the first thing you would do is you would distribute the x into this x minus 3. So without actually doing the multiplication, it would look like this, because we would then multiply the x through, and then we would distribute this 2 into the x minus 3, so it would then be plus 2 times x minus 3. So the reason why I wanted to do it this way, showing you what it looks like when we're multiplying through, is when we're factor by grouping, remember, we're working in reverse. So that's as if we were starting with the problem, x squared minus x minus 6, and we're trying to figure out, okay, what did we multiply together? Well, when we're factor by grouping, we have to have this here where it shows a term being multiplied by a binomial and then another term being multiplied by the same binomial. So this is what our goal is when we're factor by grouping. Our goal is to go ahead and create this where we have the same binomial that's being multiplied by two different terms. And once we identify that, then we can finish our factoring where we take the same binomial and we rewrite it, and we only rewrite it once. And then we take the two terms that were being multiplied to it, and they get written in their own binomial. All right, that is our steps for factor by grouping. All right, now let's just go ahead and do some problems with this. But remember, the key thing is four terms, four terms, four terms, four terms. All right, we look for this when we have four terms. All right, now let's go ahead and do this. Now, one, the directions tell us to factor by grouping, but we would know that we need to factor by grouping with this anyway because we have 1, 2, 3, 4 terms. All right, so that lets us know we're going to try and factor by grouping. So when we're factor by grouping, it's exactly what it sounds like. We're going to group some of these terms together, and what we do is we group the first two together, 2x cubed, not squared, 2x cubed, minus x squared. So we group the first two, then we always add in between, and whatever sign this is follows the next grouping. So since it's positive, we just write 4x minus 2. So we always put the plus in between. So even if this is a minus sign here, as you'll see in another problem, even if that's minus, this is still a plus here. The minus sign will just get written in with this term. All right, so by factor by grouping, we're first grouping our terms together, the first two and the last two together, right? Then we look to factor each group. Well, here we see we have an x cubed and an x squared, so I know that I can factor out an x squared out of here because that's common in both. So I can then divide each one by x squared, so then I'm left with just 2x, and x squared divided by x squared is then minus 1, because remember, it's not just 2x. We still need to account for this term, because if we were to multiply this x squared back in, we'd have to get back to our original form. All right, so it's 2x minus 1. Then from here, what we're trying to do is now, since we know that this binomial is 2x minus 1, our goal is to get this to 2x minus 1. So if you're unsure what to factor, you should look at this first term and say, well, how can I get this 4x to a 2x? Well, then we can say, oh, well, there's a 2 that can be factored out of both the 4 and a 2, so we can factor out the positive 2. And we divide each one by 2. That will then give me 2x minus 1. So we've reached what our goal was, is to get the same binomial being multiplied by both terms. And now we can finish this off. So the two terms that were being multiplied to our binomial get written together in one binomial. So it's x squared plus 2. And then the binomial gets written once, and this is our final factor form. So if we were to multiply this together, it would bring us to our original problem. Right? That is factor by grouping. We're going to do a couple more examples as well. All right, with this problem here, it just says factorize, and when we first look, it does appear that we do have 4 terms, so we can say we're going to do factor by grouping. However, if you notice, these two are like terms, so if you were to solve it like this, I wouldn't really care if you did this on a test. 3x minus 4x is minus x minus 12, and then if you want to go ahead and use the x method for this one instead of factor by grouping, that's perfectly fine with me, so we know that this is multiplication, this is our addition, so we multiply our first, which is a 1, with our third term, so it's negative 12. This middle term just drops, so it's minus 1. So now we're looking for numbers that multiply to negative 12, that add up to negative 1. And since this is minus, we know that it needs to be plus and minus, or else they can't multiply to be negative. And then we know 4 and 3 will multiply to give us this 12, and they have a difference of 1. And since this is negative, the 4 needs to be negative, the 3 is positive. Then we need to divide each one by that first letter A, that first number, so we divide it by 1. And then we can use the Drake song. We started from the bottom, now we're here, so it's 1x. So it's 1x minus 4. Started from the bottom, now the whole class here, so then it's 1x plus 3. Remember, you do not have to write the 1x. All right, but now let's go ahead and do factor by grouping if you wanted to for this one. So the first thing we do is we group the first 2 problems together, the first 2 terms. So it's 2x squared and 3x. And remember, it's always, always, always plus in between, no matter what the sign is. Since this is a minus sign, all that means is it needs to go with this minus 4x inside the parentheses. All right, if you do not do that, you're not going to be able to factor by grouping. Now we go to factor. We see we have an x squared and an x, so I know I can factor out an x out of each term. And when I divide each one by x, I'm left with x squared plus 3. So now, I'm sorry, not x squared. We're left with x plus 3. So now we want this to be x plus 3. Well, we see minus sign. So that immediately tells me I'm going to be factoring out a negative. And since both have a negative and 12 and 4 are both factors of 4, I'm going to factor out a negative 4. And when I divide each one by negative 4, I'm left with positive x plus 3. All right, now we got what we wanted, where we have the exact same binomial. So then we just combine these two together. So it's x minus 4 times x plus 3. All right, you see we get the exact same answer, and it does not matter which way you do it. But this one is factor by grouping, and you could have done this because immediately it was written with 4 terms. But most of the time, this question will be presented in this form where it's written as 3 since they're like terms. All right, there's one more problem. That's it for this video. All right, so for this one here, if we went to factor exactly how it was written, 3ab, 3ab plus d, so we group these two together, plus 3ad plus b. We won't be able to factor anything here because there's no common terms. abd, adb, there's nothing that's the same between them. However, if we notice, this one has a b and this one has a b here, so if we could somehow write the b in this group and the d in this group, because this one has a d as well, then we would be able to factor. So what this is showing you is sometimes you need to rearrange your problem first before you can factor by grouping, right? Sometimes if it's with x squared, x cubed, so if you go back to this very first problem real quick, if it's written with all the same variable, you need to make sure that it's in descending order. So x cubed, x squared, x first, x 0. So you would need to make sure it's in that order for you to factor. If it's different variables like it is here, then you just need to rearrange them to make sure that you have the same variable written next to each other. So here we have 3ab and we have a b. So I'm just going to rearrange these. And I will group 3ab plus b together. And then I'm going to do plus, and then I'm going to group these two together since they both have the d. So it's 3ad plus d. Right? Now I'm going to go ahead and factor out that b. And I'm left with 3a plus 1. And then I'm going to go ahead and factor out the d here. So I'm left with plus d, and it's 3a plus 1. Now that we have the exact same binomial written twice, being factored by both, we can go ahead and rewrite these two terms in one binomial. So b plus d, and then it will be multiplied by 3a plus 1. All right? That is our final question. That's our final part for this problem here.